Hello, viewers. This is Mr. Victor Shouters, learning with Clarkson's tutors. Today, I'm going to take you quickly through how you get the nth term formula for quadratic sequences, right? So I'll quickly give an example of a quadratic equation, a quadratic sequence, sorry, that we're going to be using as our example. So you have 6, we have 6, 19, 38, 63, and 94. That's our quadratic sequence. Now, all quadratic sequences, just like quadratic formulas, they have a general formula of nth term is equals to an squared plus bn plus c. They all have that general formula. Okay. Now, let's quickly get the first difference would be that gives us 19 minus 6. That's that 13. That 8 minus 19, that's 19. 63 minus 38 gives us 25. And 94 minus 63 gives us 31. Then the difference there, 19 minus 13 is 6. 25 minus 19, another 6. 31 minus 25, another 6. So there it is. Now, we are going to consider, now if you watch the previous video I shared on cubic sequences, we'll consider these numbers and equate them to expressions, okay? So for that row, the difference will be equated to 2a. Now, the second difference, the first difference will be equated to 3a plus b. And then the first term will be equated to a plus b plus c. Good. Now let's start. So 2a, so the 2a will be equated to the 6. So 2a is equals to 6. So a will be 3. Using divisibility property, you divide by 2 on both sides. Then 3a plus b will be equated to 13. So you get 3a plus b is equals to 13. Is equals to 13. But our a was 3, so substituting there, we get 3 times 3, which is 9, plus b is equals to 13. Using the subtractive property, we get b is equals to 13 minus 9, which is 4. Okay. Then a plus b plus c will be equated to the first term, which is 6. Now, that is equated to the first term, which is 6. Now, a was 3, plus b, which was 4, plus c should give us 6. That is 7 plus c is equals to 6. And c will be 6 minus 7, which is negative 1. So we have our a is 3, we have our b is 4, we have our c is negative 1. So now simply substitute it into the equation, and you get the nth term for this particular sequence is going to be, our first term was 3, so 3n squared, 3n squared plus bn, oh, I forgot to put an n there, plus bn, and our b is 4, so 4n, and then minus 1 because our c is negative. This is the nth term formula to get any term in this sequence. Let's try proving that it's actually true. We could try getting the second term, which is 19. So let's say using our formula. So second term is equals to 3 into brackets It's the second term and represents the position of the term, squared plus 4 multiplied by the second term minus 1. So 2 times 2 is 4. That is 2 squared. 4 times 3 gives us 12. Then 12 plus 8 gives us 20. Then 20 minus 1 is going to give us 19. So our nth term formula is correct. We proof checked and we get the second term as 19. Now that's the first method you could use. So you're going to choose between these two methods I'm going to show you. So our nth term formula was 3n plus 4, 3n squared plus 4n minus 1. Now there's a second method you could use. Now this is called the difference of the difference formula. Now this goes this way. So I'm going to erase some parts. And you're going to prove if actually you get the same answer we have for the nth term. So this one doesn't, we don't need the quadratic, the general formula for quadratic equations or quadratic sequences that I just put up there. So now this is what we do. So this one has a formula. So the difference of the difference formula, we say the nth term. Let me use a different color for clarity. We say the nth term is equals to A plus D into brackets n minus 1. Then plus, we get into brackets n minus 1 into brackets n minus 2. And then you get C over 2. Now let me explain what each one means. So A represents the first term. Right? D represents the first difference. Right? And C represents the second difference. While N is the position of the term, of course, position of the term. So you're going to substitute in A, D, and C, and you leave N, because N could be any position. So then you say the nth term is going to be, the first term in our sequence is 6 plus, the first difference would be, so we take the first difference, it's right there, and that gives us 19 minus 6 would be, we got 13. So you put 13 there, right, into brackets, n minus 1, then plus, into brackets, n minus 1, and then into brackets, n minus 2, and then C is the second difference. And remember, got the second difference was, our second difference was 6. Remember that? Our second difference was 6. So it will be 6 over 2, which gives us a 3. Right? 6 over 2, and that gives us a 3. Okay, maybe for, yeah, that gives us a 3. Okay, so this is separate. That gives us a 3. Now, let's see, we expand, so we get the nth term is equals to 6 plus 13n minus 13. And then let's expand this. So plus n squared. Remember how you did this and that, the same one with that, then this and that, and then this with that. Okay, so we get n squared. I'll just do this because there's still a 3 we're going to multiply with. N squared minus 2n minus 2n minus n plus 2. Everything should be multiplied by 3. So the nth term is equals to 6 plus 13n minus 13. Now expanding that gives us plus 3n squared, then plus 6n, minus 3n plus 6. Let's collect the like terms. So 6, then let me begin with the n squared. So let me begin with the n squared. So you get nth term, I'm going to use a different color. So nth term is equals to, this one has no like term, so we start with 3n squared plus, let's collect 13n minus 6n gives us 7n. 7n minus 3n gives us plus 4n. Okay, and then I go to the constant, -3, -13. -13 plus 6. No, 6, there's 6 there. Minus 13 gives us -7. -7 plus 6 gives us -1. And we get the same nth term formula, same as the one we have here. So you choose the one you're more comfortable with. So that's how you get the nth term formula using using the three expressions, and you can use the compressed nth term formula, which is a plus b into brackets n minus 1 plus n minus 1 into brackets, then n minus 2 into brackets, then also the brackets you get c over 2. So choose the one you feel comfortable with and work with it.